Good morning, everywhere, all around in Europe, to all of you. It's great to have you here. So welcome to our stakeholder workshop organized by DNAqua Net. It's a great pleasure. We have today many hundred people watching us here. So we have people from Belgium, Luxembourg, Bosnia-Herzegovina, Cyprus, Greece, 370 participants in Cyprus and Greece, France, Germany, Hungary, Italy, Netherlands, Norway, Portugal, Slovakia, Sweden, Switzerland, and Turkey and Finland will have their workshop soon. Also people from Denmark, from Austria are listening. It's great to have you here. We have organized a short workshop today at the first international and then national level. I would like to briefly introduce you to the network that stands behind this workshop. That's DNAqua Net. So may I see my slides, please? Yeah, my name is Florian Leese. In case you don't know me, I'm chair of DNAqua Net, which is a cost action. Let's move to the next slide. So today it will be about nucleic acids, about DNA and DNA-based methods. So we trust genetic methods in various sectors of our life since decades, when it comes to paternity tests or forensics, or at the moment, corona tests, which are often, RNA screens. We know they can also have errors, of course, but they are quite useful. Let's move on. So what about biodiversity assessments and biomonitoring using genetic methods? There's also quite a lot of improvement, and this was obvious since 10 years. Maybe even longer when we look to the DNA barcoding campaigns. So we know each species can be identified using the genetic material it contains. And already in 2012, in various countries, networks formed to ask about the suitability of these methods for inclusion in routine monitoring programs. Biomonitoring 2.0, it was termed by that. So what we did back in 2015 was probably the obvious. We formed a network to also do what other countries have started to be doing in Europe. So the aim of the proposal of a cost action network was, and still is, to advance the application of DNA-based tools for biodiversity assessments and to develop a roadmap to include these in standardized bioassessments of aquatic ecosystems in Europe and beyond. So this is of global importance. We included from the very beginning partners from all around the world. Next slide, please. Very obvious is, if we talk about bioassessments of aquatic ecosystems in Europe and beyond, this can never be only an academic exercise. We want to have real impact. It's all about not us or our disciplines, it's about our planet, nature, ecosystems. We rely on ecosystems. So the question is, how can we do our best to protect them and better manage them? So it's very important that we have people from the applied side. So many of you listening today are people from the applied sector. We really need to work together, bridge the gap between academia and application sector. So DNAqua Net, the vision is to really get tools into practice. So where can we complement the current monitoring system? We organize our network around 5 working groups. You see this in the upper left here. There is working group 3 that deals with lab and field protocols. Which methods are suitable, which not. Working group 4 deals with the data. When we get data, how do we deal with them? How can indices be calculated based on these novel data? And working group 2 then actually tests how can indices be calculated and how comparable are they to traditional metrics? Because if there's one thing we have to keep in mind, we should never use methods that completely break the continuity to past methods. We need continuity. The bottom layer of DNAqua Net probably are working groups 1. Working group 1 deals with reference databases. We have to assign taxonomy to our DNA molecules, and therefore we need reference databases. And working group 5, which deals with the implementation. because it's a lot about legal frameworks, and we have to ask, how can new methods actually be moved to the sector of real biomonitoring as part of legal frameworks. DNAqua Net has between 400 and 600 members. It's difficult to count because we have different subgroups as well. 49 countries are involved. We have so far more than 100 scientific publications, but also stakeholder reports, many research exchanges across countries, many meetings. Next slide, please. The general options when we talk about DNA-based methods in order to do bioassessments are twofold. So, I mean, it all starts with the sampling, either a water sample or a macrozoobenthos sample or a phytobenthos sample. And then instead of identifying the samples using traditional methods and keys, you sequence them, you bioinformatically process them, but then in the end, you also get to an index. So one click further, you will see, in general, there are two ways to proceed. On the left hand, you see the traditional way of doing the assessment, and on the right hand, you see options of a DNA-based assessment. And the option one is you do DNA extraction, you sequence, and then you get O2 lists. O2s we will learn about in our national stakeholder workshops are operational taxonomic units, which then need to get taxonomy. And this is done by a taxonomic assignment. And then you can proceed, although the data will always differ somewhat from traditional samples, of course. But there's also a second option, so one click further, which is the so-called taxonomy-free. It actually is not taxonomy-free, but this uses all the additional taxa that have even not been discovered right now or have no formal species name, but they may have a very important bioindication value. And we can also use this, but this will take a lot more time because it needs to be rigorously calibrated. I just want to show you there are two different options. So let's move forward one step. Just to show you some of the highlights and some of the faces of DNAqua Net. DNAqua Net is a really lively network with many excellent researchers. Some of these you see here are leading workshops today. So we made gap analyses for European reference databases. Next click. And we thought about implementing these options. What are possibilities in Europe? Next click. What indices can be calculated? What's the inherent further potential in DNA-based data? Next click. We are working on a practical guide that kind of pulls all the expertise together, because if there's one thing we need, it's guidance. Yes, and how to check reference databases, just a new publication coming out. Yeah, let's continue. So there are many challenges. There are many challenges. As always, when something new starts, there are many challenges. But where are these? And this is what we have to discuss. There are conceptual challenges, technological challenges. There are perceptual challenges, but also economic and legal framework challenges. The abundance, we will talk about that later. Let's click further. This is a nice study done by one of the DNAqua Net members from France. I would like to quickly show you one slide that highlights the potential of eDNA-based methods. This is a survey done in the River Rhône by Didier Pont and his team. And what you see is different stations along the river analyzed using eDNA and electrofishing. So blue is traditional assessment of fish diversity, y-axis is species richness, and the red squares are eDNA assessments. And what you see, the blue circles are eDNA assessments in an individual year. And the arrow bar shows what's the difference among the different years. And the triangles show you the long-term fish diversity assessed at a certain site. So what you see, 1 year eDNA basically captures fish diversity at that site seen at the long-term perspectives much better. And it's very easy to do. You just sample water and you get the molecules that the fish release into the water. Next slide. But we also have to talk about problems. Abundances are difficult to get with eDNA or DNA-based data. abundance is essential. Biomass is essential in ecosystem assessments. But maybe for the index calculated, it's not so important. So to be very honest, I think abundance is important. We should never tell people that abundance is not important. In ecology, it's really important, biomass and abundance. But for the index we calculate, it's sometimes not. These are studies from the Netherlands, when you calculate an index based on abundance data, that's on the x-axis, and without abundance data, that's the y-axis. And you see there's a very good correlation. So for the assessment as part of Water Framework Directive, it may work. We have to look at that in detail. On the right hand, you also see an example from macroinvertebrates where it works nicely. There are some outliers you see, but you see for diatoms, it's also difficult. So that's the lower one. So it may work, but it needs really close inspection. Next slide. This is a case study from England where they counted fish in a pond and they weighed every individual fish. And before that, they took samples from the pond and they looked whether eDNA read numbers reflects the abundance or biomass. And what you see, well, yeah, there's good evidence that there is a correlation. So I think there's a lot of hope that not only presence-absence data will be provided by the new methods. There's more hope in here. Next slide. Then the question is, how comparable are the data? It's kind of a new technique. We have to ground truth. Do different labs produce similar results or not? And this is a recent case study done by DNAqua Net diatom working group. So diatom samples or biofilm was collected, then DNA was extracted, and the traditional, then the DNA-based assessment was done. And then what was done was the same samples were sent to 18 labs in 15 countries. And we'll just take a small snapshot out of the results. So that's on the next slide. So if all labs use the same Taq polymerase, these are the results. A, B, C, D, etc. are the different labs, 18 labs in 15 countries. And what you see on a controlled mock community, top row, and on a real river community, the community that was recovered, the different colors, was extremely similar. Most important, next slide, how was the index that was calculated? How much did it differ? And what you see, that's the IPS diatom index. It was very similar. And on the right hand, you see the calculation of Z-scores. And a Z-score smaller than 2 is considered as satisfactory. And you see all of them, with one exception, are satisfactory. One is still quite questionable, but not unsatisfactory. So, and this is even true if the different labs use their own Taq polymerase. So the methods are quite reliable. Next slide. This was a fun experiment done also by DNAqua Net members during a conference on fish. There was, a child pool filled with water from a river. And then each of the members, or some of the members, came and just took eDNA samples from this child pool with river water. And they did whichever method they wanted to apply. So that's what you see on the lower left. Very different workflows to process the data. And what came out, that's on the lower right-hand side. Very consistent results. You see the different species, and the circle is the abundance of eDNA reads for the different species. All the different, very different methods applied consistently recovered the most abundant fish species. You see some deviation in the very rare fish species. So this shows, yes, different workflows can provide very similar data. Next slide. What we now need are co-designed validation studies. The method, I think, is quite ready in many cases, not for all biological quality elements, but we need to ground truth it. We need to validate, we need to standardize. And many things are going on. We will talk about this today as well. This is a publication from the Nordic countries, metabarcoding for use in Nordic routine aquatic biomonitoring. DNAqua Net has validation scales published and also a guidance document under preparation. Next slide. We also have to talk about, if we move to these tools as a complement, where to do the analysis. Do we have the infrastructure? Maybe some of you are, but others may not be aware. We have fantastic European infrastructure, European Open Science Cloud, Elixir, European grid infrastructure. Some countries are members in LifeWatch. It's also a research infrastructure. So we need to use these infrastructure, and then we can really all link to the same resources, but still, for example, reference databases need to be improved. Next slide. Knowledge transfer is important. So there's also a new standardization group as part of CEN, which kind of brings all the consensus we have together. It will more be about minimum requirements. We should not dictate which tech polymerase or primer to use. Next slide. Yes, and look forward to these new publications coming out. I would to highlight specifically from Switzerland, there's a recent fantastic guideline document. That's what you see on the lower panel here from DNAqua Net members in 3 languages. This is extremely useful. We need more of this. Next slide. Yeah, the main emphasis of my talk is to raise what this is all about. This is not about technique A or B or C. In the end, it's all about our ecosystems, which is the basis of our civilization. We have to protect and better manage them. And this only works if we have the best tools. DNA tools may not be the best in all cases, but they are very useful in many of the cases, not in all. So where are they useful and how can we use them? This is the vision of DNAqua Net. And I hope we all will have a very good workshop to further identify chances, but also challenges. With this, I would like to hand over to Agnès Boucher.
Hello, everybody. It's my pleasure to be with you this morning. I'm Agnès Boucher. I'm a senior scientist at INRAE, which is a French research institute. And I am also vice chair of this cost action that Florian just presented to you. So today I'm going to speak about some work that has been done in DNAqua Net about the implementation of DNA-based tools for biomonitoring. As all of you knows, aquatic ecosystems are so important for us and we really all want to protect them. And so to protect them, we need first to monitor them, but to monitor them, we really need to rely on a good knowledge. And the ultimate goal in this protection would be to be predictive. For that, as Florian just showed you, there are some new DNA-based methods that can be used for species detection, for example, of endangered species or invasive alien species or parasites. And this could be used for conservation goals. And you can also use DNA for biodiversity survey for different group of organisms. And third point, you can also use eDNA for bioassessment and biotic indices. But include that in monitoring practices, it's not straightforward. And it requires harmonized actions for sure at national and international levels. So as Florian presented you just before, there are 2 different options for using DNA-based methods in ecological status assessment. One is to improve the identification by using barcoding. That means that we will use a different way for identifying organisms. And the second one is use fully new metrics using the full advantage of DNA-based techniques. And between both options, there are, of course, a full range of hybrid options. For option 1, in many cases, it should be quite straightforward to implement, especially for some BQEs that are more advanced than others, like, for example, diatoms. But for option 2, for sure, that would not be before 2027, and that needs to be very well prepared. So option 1, that would be to replace specific steps of the conventional assessment by DNA-based methods. So we will replace, after the sampling, we will replace all the parts that is doing morpho identification, and we will do DNA-based identification. That has many advantages, like improvement of processing speed, comparability, cost efficiency, and it can be implemented on the short run, most likely to be applied until 2027. More than 40 pioneering projects were already done when we inquired for that with Working Group 5 in 2018. For option 2, we will need to develop fully new indices based on the eDNA data that has the advantages of higher taxonomic resolution and probably to get closer to the information of ecosystem functioning. However, it's a longer process to develop, and it cannot be directly implemented. We will need new standardization and intercalibration, because probably boundaries for quality status will be changed. So to foresee and to stimulate this process, with Working Group 5 of DNAqua Net, we hold prospective online workshops last spring. It was supposed to, at the beginning, to be a meeting in Paris, but due to Corona situation, we went on to a series of workshops organized by INRAE and DNAqua Net, with members of DNAqua Net, of EcoStat, and other environmental biomonitoring stakeholders all over Europe. And together, we thought about which actions should be taken at national level and which collaborations should be organized and which steps should be taken at EU level. So there were 51 participants from 18 countries. In each country, we had both scientists and decision makers. And you can see here on your left the different participants. Sorry, it was a bit fast. So you can see different participants here. So here you have just a few pictures from our workshops. It was good to see some people during this spring period where we were all in our houses and we had really good discussions. So we developed a shared roadmap with 6 different components, and I will go shortly in each of the components that we discussed on this roadmap. So first component was to develop an adaptative approach and a steady implementation of new methods. Because most of DNA-based methods are now mature enough to be implemented into biomonitoring and to meet end users' needs. But how should we process? Should we proceed? Should we wait until methods are fully tested and evaluated and calibrated? And for sure, in this case, optimization of method is an endless task. And we should ask ourselves at what stage is it sufficient of development? Is it sufficient to move to the operational phase? And should we wait until there is no more questions? Or should we adopt a more adaptative approach where harmonization and comparability of the methods will be then a challenge? And the workshop's discussion ended up focusing on approach B, a more adaptative approach. Then we discuss about how to demonstrate the effectiveness and the benefit of DNA-based methods. And for that, we thought that it was really important to really understand the manager's real information needs and to respond to them. So in one hand, when traditional methods are satisfactory and are required by regulation, the implementation of DNA-based methods is not a priority, but really it would be interesting to focus on topical management issues that are not yet addressed by regulatory monitoring. For example, monitoring the impact of restoration actions or of biodiversity, of endangered species, of the impact of multiple pressures, and also work on some neglected water bodies, for example. And so for that, we will need to develop new indices that are adapted to the new data to take full advantage of this data, of this DNA data. There will be an opportunity also to reduce differences between European regions and countries. That was clearly identified during our workshops. Then we had this component that was to back the profound change in the biomonitoring sector. So we discussed about how we should create the conditions so that private companies invest and get involved in these new technologies. And we thought that it was very important to demonstrate that implementation of DNA-based methods is not only a cost-effective solution, but it's also something that could improve biomonitoring, provide more information that would be useful for decision makers, and that will be also in line with citizens' concerns. Then another component was to transfer knowledge to all stakeholders. And for that, we need communication and training that will be very effective. And that should be going hand in hand with implementation, for example, through pilot studies. And for sure, joint training sessions between different stakeholders would be also very beneficial. Finally, we have to harmonize efforts at European level, and that was really a major thing that was discussed in our workshops, that we really need collaboration between European level and scientists, and for example, ECOSTAT, to discuss and foster implementation with a clear mandate, for example, sharing knowledge, produce recommendations, and so on. And in this kind of EU collaboration, we should provide a common framework for member states and that would help obtaining national and European funding for further development. And to finish, the final component was to provide best practice guidelines and standards with a flexible approach. So to have first guidelines and guides to good methods and practices for an overall framing, and also some imposed methods and standardization for key stages, for example, such as sampling. And for example, we have already 2 technical reports that were provided in SEN TC 230 for diatom metabarcoding after 12 years of efforts, I have to say. And now, due to the efforts of DNAqua Net, we now have a new SEN working group in TC 230, working group 28, that is dedicated to DNA-based methods for aquatic biomonitoring. This working group is led by Christian Meissner from Finland. So there is work in progress at this working group. For example, there is a draft that is about water sampling for capture of environmental DNA in aquatic environments. And this draft is expected to go in the official pipeline soon, and standards could be out in 2021. Finally, as Florian already showed you, there is some guidelines and proposed protocols and framework for different from different projects. One from Switzerland on your right, one from DNAqua Net Working Group 3, and also there were European programs such as Equals Water, which provided numerous protocols. You could see them in the website of Equals Water. And finally, I want to take final messages from our big conference that was held in the 3 previous days. So this DNAqua 2021 conference raised a very large interest, and we were quite surprised to have such a large interest that was all around the world, with 1,500 people that were registered from 79 countries, with participants both from academic, public, commercial sectors. And finally, Florian yesterday gave us some hot take-home messages from a working group 5 session that was about implementation. So for sure, genetic assessment methods can improve aquatic bioassessment and monitoring. But taxa list obtained will always differ, that's sure, and because we are not looking at the same thing. And as genetic tools systematically measure differently to traditional assessment. So we have to take that into account. Standardization at international level seems to be a priority. We also need validation studies that are co-designed, co-implemented through Europe. That's very important to this co-organization. And we also need to, in these validation studies, to involve experts also on legislative aspects. Okay, and with that, I will finish and thank you. And just this picture to show you that we had a report from the workshops that you can access on the web. So thank you very much.
So here I'm back. We will move now to the national stakeholder workshops. And we have 3 more slides to show you what's next when we will move all to our national, or sometimes 2 countries do this workshop together. So, I mean, the main aim is we need to work together, bridge gaps between application and academia. And there are a couple of aims and a couple of, and one big announcement for this. So can we move to the next slide? First to the aims. Next slide. So today, the main aim, number 1, or there's a block of first aims. We want to present to the national stakeholders state-of-the-art of DNA and eDNA-based tools, and then discuss details when it comes to bioassessment and monitoring, reference databases, quantification, taxonomic assignment, how costly are those new methods when it comes to the purpose of routine monitoring. And also very important, we would like to link the community through this workshop. So link you with experts from either the applied or the academic side. And then the second set of aims is, we would like to hear from you. What are the methods that are already used in your country, if at all? And where do you see use of that? And what are the main obstacles? So at your country, some countries are using some of the methods already routinely, but some haven't started properly by now. And the question is, why not? Is there an interest or not to start this discussion? And DNAqua Net has something to show you. I would like to hand over to Charlie, the manager of Cost Action. We would like to formally collect some information. Probably the next slide.
Yeah, good morning, everyone, and also welcome from my side. My name is Charlotte Frie, and I'm the manager of DNAqua Net Cost Action since last autumn. Yeah, I would like to take the opportunity to introduce a survey for this series of stakeholder workshops in Europe. Yeah, the topic of the survey is to investigate the current state and future needs of the use of molecular methods in monitoring. The survey was developed by Syke, the Finnish Environmental Institute. The goal behind the survey is to find out what kind of obstacles exist in the implementation of molecular methods into regulatory monitoring. Yeah, and especially to figure out what stakeholders see and experience as obstacles. Yeah, the survey is also a great opportunity to get these impressions from all across Europe during the stakeholder workshop series. Yeah, the questionnaire contains 23 questions and was translated to all languages of the participating countries, and it will be distributed to you by the local organizers. Yeah, it can be filled out during the break or just after the workshop. And the international questionnaire in English will also be open until the end of April under the following link you can see in the slide. Yeah, that's it from my side, and I wish all of you a good and fruitful workshop. Thanks.
Yes, also from my side, it's fantastic. We have 600 people here, 530 via YouTube, 700 via Zoom linked here. So it's great that so many of you had the chance to connect with us. Yes, and now let's move to the national stakeholder workshops after a short coffee break. Goodbye.
Bye-bye.